Hey everybody, here are a few extra examples of multiplying and dividing polynomials, as well as at the end I have a few bonus examples of factoring polynomials, which is going to be the material in class D. So let's look at some examples of multiplying polynomials. People have heard of FOIL, means first, outer, inner, last. That's really only good for a two-term thing multiplied by a two-term thing. What you really want to happen is just to make sure that each thing in this, I should say each thing added or subtracted together in each parentheses multiplies each other thing in the other parentheses. So here, I need to make sure that 2x multiplies by 3x squared. So you get 2x times 3x squared. And then 2x has to multiply the negative 4x. And then 2x is multiplied by everything in this other one. So then I move on to the next thing. The 5 multiplies the 3x squared. I'm probably doing more work than I need to here. And the 5 multiplies the negative 4x. Normally we'd actually just like do the multiplication. So instead of like writing 2x times 3x squared, I would write 6x cubed, right? Because that's x to the first times x squared, which is x to the third. And then here, the 2x times negative 4x is going to give me a negative 8 times x to the second. 5 times 3 is, I get a 15x squared. And finally, 5 times negative 4x is going to be minus 20x. And then I should simplify as much as possible, meaning any powers of x that are the same, I should combine those terms together, or I should add or subtract their coefficients. So I'm going to simplify this. And that's what usually the typical way of writing this is from highest power to lowest power. So 6x cubed first. Negative 8 plus 15 is 7, so it's going to be plus 7x squared minus 20x. Should leave it like this. Don't try to factor it, even if it can be factored, because we're just trying to write this in the typical kind of way of expressing a polynomial, which is highest power is first, lowest power is last. All right, this next one, you're going to see more of what I was talking about in that we have a three-term thing here. I guess you call it a trinomial if you really wanted to, and a binomial here. It just means two terms. We're going to multiply each of these things by each of these things. So we should get 6 things altogether before we start simplifying it. So my hair crazy. So first I'm going to do the 2x multiplied by each thing. And actually I'm not going to write down the intermediate step. I'm just going to do it. So 2x times 4x squared, 2 times 4 is 8. X times x squared is x cubed. 2x times 6x is going to be 12. X times x is x squared. 2x times 9 is 19x. 19x. And then I have negative 3 multiplied by each of these things. So I'm going to get minus 3 times 4x squared is minus 12x squared. Minus 3 times 6x is minus 18x. And minus 3 times 9 is minus 27. And then we're going to combine like terms. So 8x cubed is the only x cubed term. It's going to be 8x cubed. Look at the full pen here. I have a positive 12x squared and a negative 12x squared. Those are going to add to 0x squared. Normally I wouldn't write this term here, but I'm going to this one time. I feel like I made a mistake here. I said, I think I feel like I said 18, but I wrote 19 somehow. Right, that was a 2x times 9 should have been an 18x, not a 19x. And notably, this 18x and this negative 18x also add up to 0. So it's going to be plus 0x. Again, normally I would not write this. And finally, minus 27. Not writing those two terms there, we really should write this as 8x cubed minus 27. One thing I want to point out is that this is actually a difference of cubes. So 8x cubed minus 27 is really 2x quantity cubed minus 3 quantity cubed. And you can always factor a difference of cubes as the first thing minus the second thing, so 2x minus 3, times the first thing squared, plus the first thing times the second thing, plus the second thing squared. And that's exactly what we started off with. 2x minus 3 times 4x squared plus 6x plus 9. It's kind of a fun fact. But we didn't have to know that to do that problem. All right, so now some polynomial division. So actually, one of the reasons I wrote those 0x squared and the 0x there was because we actually kind of need them here. So when you're doing polynomial division, the thing in the numerator, also called the dividend, goes in the division, long division symbol, and the x minus 2 is the divisor. It goes out in front. So we're going to rewrite this as x cubed. So here's where I need the other thing. I want every power of x after my highest power. So I really would like an x squared term as well. It just makes life easier. So I'm going to write plus 0x squared, even though normally we don't need that. It is useful here. Plus 4x minus 16 divided by x minus 2. And then the way we approach this typically is to ask ourselves, for the highest power here, which is x to the first, what can we multiply by x to the first to get x cubed? Well, the answer is x squared. But then we multiply that x squared by the entire x minus 2 here, not just the first part. X squared times x, of course, should be x cubed. That's why we picked x squared. X squared times negative 2 is negative 2x squared. And then we subtract, just like with regular division. The way it should usually work is the first thing minus the first thing should be 0, right? X cubed minus x cubed is 0, or 0x cubed. We're not going to write it because we don't need it. 0x squared minus minus 2x squared, minus and minus is plus, so that's going to be 0x squared plus 2x squared, which is 2x squared. We bring down the next term and we repeat the process. So then we ask the question, what do we multiply by x to get 2x squared? And the answer is 2x. 2x times x is 2x squared. 2x times negative 2 is negative 4x. Repeat, subtract. That minus that is 0. 4x minus minus 4x is 4x plus 4x, which is 8x. Bring down the next term, repeat the process. What do we multiply by x to get 8x? It is 8. 8 times x is 8x. 8 times negative 2 is negative 16, and these look exactly the same, meaning when we subtract them, we should get 0. 8x minus 8x is 0. Negative 16 minus negative 16 is 0. That means it divides in perfectly, or evenly, whatever you want to say. So we could write our answer as just, and I kind of like to write an equality here. Sorry, I've left the pen I was looking for. 1 second. So I would probably write my answer as x cubed plus 4x minus 16 divided by x minus 2 is equal to my quotient x squared plus 2x plus 8. It's nice when there's a 0 remainder because you don't have to add on the little other part here, which we will in the next one, I think. So let's look at another one. Maybe we've got 1 or 2 more, yeah, before we have a couple other things. Hopefully I'll have myself enough room here. So same deal here. We're going to start with the usual setup, where we're going to rewrite it as x minus 3 dividing into x squared plus 5x plus 6. Or read in a more typical way, x squared plus 5x plus 6 divided by x minus 3. Same sort of questions. What do you multiply by x to get x squared? When you do this, you do want to write each polynomial, both the dividend and the divisor, from highest power to lowest, the standard way of writing them. Then we multiply x by both things here, so you get x times x is x squared, x times negative 3 is negative 3x. Subtract. You can do the thing where you like change the signs. It's not what I prefer to do. I like just subtracting like this. X squared minus x squared is 0. 5x minus minus 3x is 5x plus 3x, which is 8x. Bring down the 6. X times 8 will give me 8x, so I need a plus 8 here. 8 times x is 8x. 8 times negative 3 is minus 24. Subtract. 8x minus 8x is 0. 6 minus minus 24 is 6 plus 24, which is 30. And now 30 has an x to the 0th, if you want to say that, but the degree here, or the power of x here, is less than the highest power of x here, meaning we have to stop, right? We can't go any further. So then here's how we're going to write our answer. And again, I like to write it as my original quotient, x squared plus 5x plus 6 over x minus 3 is equal to the quotient x plus 8 plus, well, this 30 still has to get divided by x minus 3. But since we can't do that, we're just going to write 30 divided by x minus 3. If we were to graph this, which we're not doing right now, but I just want to point out, this is a kind of function like y equal to this, whose graph would have a slant asymptote. Because if you let x get really, really large, this part becomes negligible, and you're left with something that looks like the line y equals x plus 8. You should graph it. If you have time, graph this y equals this on Desmos and graph y equals x plus 8 on Desmos and see how they're very close to each other the further you away even from the origin. Kind of neat. All right, let's look at this one here. Again, same idea. We're saying y plus 2 dividing into 4y cubed plus 3y squared minus 2y minus 4. I don't think this one divides in evenly, but I didn't actually check, so we'll see what happens. So what do you multiply by y to get 4y cubed? 4y squared. Multiply it, you get 4y squared times y, which is 4y cubed. And then 4y squared times 2 is 8y squared. Subtract. 0. 3y squared minus 8y squared is negative 5y squared. Bring down the next term. Do it again. What do you multiply by y to get negative 5y squared? Negative 5y. Negative 5y times y is negative 5y squared. Negative 5y times 2 is negative 10y. Subtract. That minus that is 0. Negative 2 minus 10y. So negative 2 plus 10y is going to be 8y. I'm really not paying attention to the y there. I'm just saying negative 2 plus 10 is 8, and then there's a y there because it's that many y's. Bring down the minus 4. What do you multiply by y to get 8y? It is 8. 8 times y is 8y. 8 times 2 is 16. Subtract. 0. Negative 4 minus 16 is negative 20. So here our original quotient, 4y cubed plus 3y squared minus 2y minus 4 over y plus 2. And I say quotient there because it is something divided by something else. And then it's equal to the quotient, like actually what you got, and then the remainder divided by the divisor. So it's equal to 4y squared minus 5y plus 8. I like to write plus even if it's a negative here, plus negative 20 divided by y plus 2, right? Because that negative 20 still has to get divided by y plus 2. That's the way I like to think of it. Helps remember what goes where. All right. Those are the examples I have for multiplying and dividing polynomials. It's not too terrible. It's just kind of an algorithmic process. I did want to give a few examples of factoring just because I figure you might get started on that if you finish that other stuff first. So I call this simple factoring when you have specifically a quadratic x squared plus lower powers of x, right? So x squared, x to the second 2 is the highest power of x. And it's simple factoring because the coefficient of x squared is positive 1. And all these are set up to work out, so they work out nicely. So when you're factoring something like this, where it's 1x squared plus something times x plus something else, you're trying to find two numbers that accomplish the following two things. You want to find two numbers that multiply to 6 and add up to the coefficient of x. Some people use the diamond method, which I never really learned. I think you do something like, I don't really know. You write one of the numbers on the top. I think you write like the one you want to add up to here, and the one you want to multiply to here. It might be the opposite of that. I don't really know. And then I'm looking for numbers that multiply to 6 and add to 7. So usually I'm thinking about what numbers multiply to 6. There's not a lot of options. It's either 2 and 3 or 6 and 1. I know it's, or I guess I could say negative 2 and negative 3 or negative 6 and negative 1, but I know I shouldn't pick the negative ones because two negative numbers will add up to a negative number, and I know I want to add it to a positive number. So knowing what I want to add up to kind of limits which types of numbers I can pick, whether they're positive or negative. So let's see, 2 plus 3 is 5, 6 plus 1 is 7. So I know the numbers are 6 and 1. What that means is this is going to factor as x plus 6 times x plus 1. And that is the whole problem. This shouldn't be set equal to anything. We shouldn't be trying to say x is equal to negative 6 or x is equal to negative 1 because we're not solving an equation that is equal to 0. So if we're just given an expression to factor, it's just going to factor like this and we're done. That's the end of the story. Let's do the same thing here. We're looking for numbers that multiply to positive 12. Oops, I wrote, so I never know which place you're supposed to put them. I'm not gonna, I really like it. I guess the 12, if I'm gonna be consistent, multiply to positive 12, add up to negative 7. So now I do want two numbers that multiply to a positive and add up to a negative, meaning I should pick two negative numbers. So I could do negative 1 and negative 12, or negative 2 and negative 6, or negative 3 and negative 4. But I shouldn't do 2 and 6, right? Because we know that adds up to a positive number. So it looks like negative 3 and negative 4 adds to negative 7. So those are my numbers. So knowing what pairs of numbers multiply to whatever's out here is a really like knowing all the possible things that multiply to 12 makes it easy to figure out which two could add up to the right thing here. So this is going to factor as x minus 3, or you could say x plus -3, but x minus 3 is equally correct, times x minus 4. That's it. End the story. We'll talk about more complicated factoring later on, but let me give you a couple more examples just because I think it's kind of fun. So we want to factor this one. So now we're trying to look for numbers that multiply to, and where I never, like I'm probably doing this totally wrong, multiply to -24 and add up to +5. So if we want to multiply to a negative, one has to be positive and one has to be negative. And we have to, if we're going to add to a positive, the bigger one should be the positive one, the smaller one should be the negative one. So let's see, the ways to multiply to -24 are +24 and -1, or +12 and -2, or +8 and -3, or +6 and -4. I'm going to leave off writing 4 and -6 and 3 and -8 and 2 and -12 and 1 and -24 because I know that any of those choices would add up to a negative number because the negative number is larger than the positive number. Let's see, 24 plus -1 is 23, 12 plus -2 is 10, 8 plus -3 is 5. That's the one I want. 6 -4 adds up to 2. So this is going to factor as, I'm just writing it over here, x squared plus 5x minus 24 factors as x plus 8 times x minus 3. That's the whole answer. Now, just to see a slightly different take on things, we can use factoring to solve a quadratic equation sometimes. So in this equation here, x squared plus 5x minus 6 equal to 0, we definitely want to leave it equal to 0. Adding 6 to both sides and then factoring out an x is not going to help us. So the idea here is to solve this by factoring. So let's see, I'm looking for numbers that multiply to -6 and add up to +5. So again, I want a negative and a positive number. So it could either be 6 and -1 or 3 and -2. Or I guess 2 and -3 and 1 and -6, but we know those adds everything. So here, 6 plus -1 is 5. Be careful here. It's really easy to accidentally think it's like 2 and 3 or -2 and -3. It's not. So this factors as x plus 6 times x minus 1 equal to 0. Now, what's interesting about two numbers that or I should say two things that multiply to 0 is that one of them has to be 0. So either it has to be true that x plus 6 is equal to 0, or it has to be true that x minus 1 is equal to 0. Solving this, subtracting 6 from both sides, you get x equal to -6. Solving this, adding 1 to both sides, you get x equal to +1. So those are the two solutions to this quadratic equation. You don't have to check them, but I'm going to check them just to show you that they really are the solution. So if I plug in x equal to 1, 1 squared plus 5 times 1 minus 6 is equal to 1 plus 5 minus 6, which is 6 minus 6, which is equal to 0. Like it's supposed to equal 0. Oh, sorry, you didn't see that. Let me say it again. 1 squared plus 5 times 1 minus 6 equals 1 plus 5 minus 6 equals 6 minus 6 equals 0. So when I plug in 1 for x here, or substituting 1 for x, I do get the right number. Let's try substituting in -6. So -6 squared plus 5 times -6 minus 6 is equal to. So when you square a negative number, and the negative is on the inside of the parentheses, it's -6 times -6, which is +36. 5 times -6 is -30 minus 6. 36 minus 30 is 6, and 6 minus 6 is 0. So that checks out. Those are the two solutions. So notice the difference, right? In this previous problem, we were just told to factor this quadratic polynomial, and we factored it, and we got x plus 8 times x minus 3. If we were told to solve that this was equal to 0, we would get solutions that were x equal to -8 and x equal to +3. In a similar way, well, actually, in a dissimilar, I should say. Here, we weren't told to factor, we were told to solve this equation, but we did it by first factoring the quadratic polynomial here, and then setting each factor equal to 0. So whenever you're trying to solve an equation that's non-linear, meaning has x to a different power than 1, like x squared or x cubed or x to the 1/2, we almost always want to start by setting the whole thing equal to 0 and then excuse me, applying some sort of method like factoring or squaring both sides or whatever is necessary. All right, I'll see you all in class tomorrow. We won't get to factoring just yet tomorrow, although I will probably bring some extra problems if you all finish the worksheets ahead of time. All right, that is all.